Hey guys, how's it going? So, my final exams ended on Thursday, if it hasn't become immediately obvious to you guys, which is why I had all these time to record these videos. So, we're going to be doing some calculus 2 today. We're going to be doing integration with partial fractions, and I'm going to show you what a typical question you might get on a homework or test and how you do it. So, the first one, the question is e to the power of x over e to the power of 2x plus 5e to the power of x plus 6 dx. And the second one is 5x plus 3 over x plus 1, x squared plus 2x plus 2 dx. So how do we solve this? Well, first of all, you should be able to recognize that this is a very good question. Let's start with this one here first. So partial fractions, we generally like to have them as polynomials. So here, we're going to use the substitution rule. We're going to say that u is equal to e to the power of x. And then that obviously means du over, du, I was going to say du over dx is e to the power of x, but I think you guys could like see it, how it works if I do it like this. So du over dx is e to the x. So du is e to the power of x dx. So that means here, it's now become du over, well, e to the power of x squared. So that's u squared plus 5u plus 6. U squared plus 5u So now we have a rational function here where we're dealing with. And we want to see if we could divide the denominator, if we could simplify this at all. But we can't simplify this, so we look at the denominator and we break it apart. U squared plus iu 6, that's I'm gonna write it like this. So 1 over u plus 2 u plus 3 du. Okay, and now we have here's what we do. So we take this from the integrand and we just consider it like this. So 1 over u plus 2, actually, you know what, I'm gonna write it like this. U squared plus 5u plus 6 is equal to a over u plus 2 plus b over u plus 3. Okay, and now what we want to do is we want to multiply u squared plus 5u plus 6 on both sides. So you end up with 1 is equal to a u plus 3 plus b times u plus 2. And 1 is equal to au plus 3a plus bu plus 2b. And we also say that 1 is equal to u a plus b, we factor it out. Plus 3a plus 2b. And now from here, it's just a systems of equations. So look here on the left-hand side, there's nothing with a coefficient of u. So a plus b has a value of 0. A plus b is 0, meaning a is negative b. And 3a plus 2b equals 1. They're supposed to have the same coefficient. 3a plus 2b is equal to 3a minus 2a, which equals 1. 3a minus 2a, which equals 1. So from this, a is 1 and b is negative 1. All right, so based on this, that means this is equal to, actually, I'm going to write it like this. So du over u squared plus 5u plus 6 is equal to 1 over u plus 2 minus 1 over u plus 3. So du over u plus 2 minus du over u plus 3. And this thus equals ln of u plus 2 minus ln of u plus 3 but we're not done yet because we have to convert it back to x, our original substitution. So this value is equal to, I'm going to say answer instead. Answer is equal to ln e to the x plus 2 minus ln e to the x plus 3. And that's the answer for part 1. Now, let's do part 2. So for part 2, we have this. I'm just gonna, first of all, just consider the integrand. There's no substitution this time for this question, but there's something else to consider here. So 5x over 3 over x plus 1 x squared plus 2x plus 2. That is equal to, so like, let's just split this up. Here we can just say it's a over x plus 1. And as you may have recalled from your previous math experience, there's no way you can simplify or factor out x squared plus 2x plus 2. But then do you just write b over x squared plus 2x plus 2? No, you don't. This is what you do instead. You do bx plus c. X squared plus 2x plus 2. So basically, whenever you have like this power, like power 2, you can't like simplify it. You take the numerator will have a degree of 1, while the denominator will have a degree of 2. If it was to the power of 4 and you couldn't simplify it, the numerator would have a degree of 3 and the bottom would have a degree of 4. So it's always degree of x minus 1, essentially, when you can't simplify it. But you don't have to worry if they make you do it over degree of like 3 for one factor, then that's just ridiculous. So yeah, this is what you do. Now let's multiply both sides by this value here, which means 5x plus 3 is equal to a x squared plus 2x plus 2 plus bx plus c times x plus 1. All right, let's expand this. Is equal to ax squared plus 2. Plus bx squared. Yeah. Okay, and all right, so it's x squared a plus b how many terms are there? 1, 2, 3, 4. Okay. It's 2a plus all right, so now we have this. let's start grouping and considering them, making their coefficients have same values. There is no term here on the left-hand side that has x squared value, so a plus b equals 0. Let's make them all in terms of a. So let's say b is negative a. And 2a plus b plus c equals 5. Since they both have the x coefficients. Plus c equals 5. A plus c is 5. C is 5 minus a. And 2a plus c is 3. Two a plus 5 minus a. Okay, so what does this mean? A plus 5 is 3, a is negative 2. B is 2. And C is 7. Right? Because 5 minus negative 2 is 7. All right, so let's see. Yeah. Integral of 5x plus 3 over x plus 1, x squared plus 2x plus 2. And now we just substitute these coefficients in. So which is equal to a, which is negative 2, x plus 1 dx plus, this is 7, that looks really, plus 2x plus 7 x squared plus 2x plus 2. Dx. All right, so let's consider the 2x plus 7 part. I'm gonna put this so you don't get confused. I'm gonna separate this part out. So let's just consider the 2x plus 7 part. I already know what the value of this integral is. Let's just consider this part first. So 2x plus 7 over x squared plus 2x plus 2. All right, here's how I'm going to do it. First of all, 2x plus 4, actually, you know what? I'm going to write it out and then explain. So 2x plus 4 can be written as 2 multiplied, actually, wait. Is equal to 2x plus 4 over x squared plus 2x plus 2 dx. Plus 3 over, and this is how I'm going to write it. X squared plus 2x plus 2 is equal to 1 plus x squared plus 2x plus 1, but that's just 1 plus x squared. And you're going to see in a second why I'm writing it like this. Okay, so now look here. A typical ln, you could use u substitution here, but I recognize this in the back of my head. The derivative of x squared plus 2x plus 2 is just, sorry, 2x plus 2. Yeah, so, yeah, sorry, I didn't mess the whole thing up. I just made a slight miscalculation. This should be 5, sorry. Very sorry about that mistake, guys. 2x plus the square root of, sorry, the derivative of x squared plus 2x plus 2 is just 2x plus 2, right? And you could use u substitution here, but I know this in the back of my head, and that's d dx. This is a side note. Is d dx ln f of x is equal to f prime x over f of x. And what do we have here? Exactly that case, f prime x over f of x, which is this x squared plus 2x plus 2. So this is just equal, this part is just equal to ln of absolute value of this, but this x squared plus 2x plus 2 is never negative, at least in the real world sense. So you can just say ln of x squared plus 2x plus 2. Because x squared plus 2x plus 2 is never negative, you don't need to put the absolute value signs. You can if you want, but it's not necessary. Plus, and here, now here, this is 5 times, and there's the 5 tan inverse of 1 plus x squared. All right, so the answer to question number 2 is -2 ln x plus 1 plus ln of x squared plus 2x plus 2 plus 5 of inverse tangent or arctan one plus x squared. And that's the answer. So we're done here. Now there's also one more case that one of my friends has specifically asked me to do a video on this part section. What if you have something like this, like let's say a over, now let me do something, let me write it like this. So what if you have something that looks like something like this, never mind what this value is, over x squared times something else. And how do you deal with this x squared? you can't simply write a over x squared. I can see why you'd be tempted, because like this, and then, initially using your own intuition, you probably would have just said a over x squared, or some people would just say a over x plus b over x. But this is also wrong, because you could just add these two a plus b together, and that's still a. So, and then it would be some constant over x. And this is not right. This is not right. The way for x squared is slightly different. It's a over x plus b over x squared. So, and if it's x cubed, you could expand it to a over x plus b over x squared plus c over x cubed, and so on and so forth, expanding that idea. As long as you guys follow my algorithms, you guys should be good. So yeah, that's all for this video. I hope you guys liked it very much. I'd love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.